Every single day, we flip switches, we plug in our phones, we're constantly tapping into this invisible network of power that runs our entire lives. But how much do we really get what's going on behind the walls? Well, today we're going to pull back the curtain and demystify your home's electrical system. So let's start with something you've probably used a dozen times today already, a simple 3-pin plug. We just jam it into the wall socket without a second thought, right? But this little thing is actually a masterpiece of safety engineering. It's the handshake between your appliance and the powerful current hiding in your walls. And that brings us to the big question. Why 3 pins? I mean, you've seen 2-pin plugs, so what's the deal with that third one, the one that's a little bigger than the others? Well, the answer to that question is really the key to understanding the whole concept of electrical safety. And look, this isn't just some fun fact to know. The stakes here are, well, they're as high as they get. As our source material makes crystal clear, when you're dealing with electricity, tiny mistakes can lead to huge, catastrophic problems. So understanding this stuff isn't just neat, it's absolutely critical. Okay, so before we go any further, let's lock in 4 unbreakable rules. Rule 1, water and electricity are a terrible, terrible mix. Just keep them apart, always. Number 2, if you see a frayed cord, that's a giant red flag. It's an accident waiting to happen. 3, using insulated tools is a must. They're designed to protect you. And the biggest rule of all, always, and I mean always, make sure the power is off before you start messing with anything. All right, let's put on our X-ray goggles. We're about to go behind the drywall and trace the hidden highways that deliver power all over your house. And the foundation of this entire highway system is the electrical cable. Now, it's not just a simple wire. The official definition calls it an assembly, and that's the perfect word. It's this whole collection of different parts, all bundled together, and each one has a super important job to do. And check this out. This shows you exactly what we're talking about. When you slice a heavy-duty cable open, it's like looking at the rings of a tree. It's built in all these different layers, and it's way more complex than you'd probably guess. Every single one of these layers is a line of defense. Right in the middle, you have the conductor. That's the road the electricity travels on. Wrapped around that is insulation, which acts like the guardrails, keeping the power from jumping off the road. Then you've got bedding for cushioning, armoring, which is literally a metal shield to protect it from physical damage, and finally, the outer serving, which is like a tough, weatherproof jacket. So we've got these power highways, but how do we actually control the traffic? Let's talk about how we interact with this flow of electricity every day. Our main tool for that is the good old switch. Its job sounds simple, but it's absolutely vital. Think of it like a drawbridge. You flip the switch on, the bridge comes down, the circuit is complete, and electricity flows. You flip it off, the bridge goes up, and you create a gap that the power just can't cross. But of course, it gets a little more clever than that. You've definitely used a two-way switch. It's that setup that feels like a little bit of magic, where you can turn the hall light on when you're at the bottom of the stairs, and then turn the same light off when you get to the top. It's just a perfect example of how simple electrical parts can work together to make our lives way easier. Okay, but what happens when the electricity doesn't play by the rules? What about when there's a power surge or a short circuit? Well, that's when your home's unseen guardians spring into action. The original guardian was the fuse. And really, it's a brilliant piece of engineering. Its whole purpose is to be the weakest link in the chain, on purpose. If way too much current tries to rush through, a tiny wire inside the fuse just melts, breaking the circuit and stopping a dangerous situation dead in its tracks. It sacrifices itself to save the system. And you can really see the evolution right here. On the left, you've got those classic old-school fuses. Once they blow, that's it, they're done for. But on the right, you have its modern, much smarter cousin, the miniature circuit breaker, or MCB. So what's the big difference? Well, like I said, a fuse dies to save your home. An MCB, on the other hand, is more like a bouncer at a club. When it spots trouble, it just trips a switch and cuts the power. Once you figure out what caused the problem and fix it, you just flick the switch back on. No fuss, no replacements. And that brings us full circle, right back to our original mystery, that third pin. Its job is, you could argue, the most important of them all. It's the connection to your home's earthing system. And it is, without a doubt, your best defense against a nasty electrical shock. So here's the deal. Let's say a wire comes loose inside your metal kettle. Without that earthing pin, the entire metal body of the kettle could become live. If you touch it, the electricity will try to find the fastest path to the ground, right through you. Not good. But the earth wire gives that faulty current a super easy, low-resistance escape route, straight to the ground, which instantly trips the breaker. And when we talk about earthing, we mean it literally. Your home's electrical system is physically connected to the actual earth. This diagram shows one way it's done, pipe earthing, where a metal pipe is driven deep into the ground, creating that safe exit for any stray electricity. Now, everything we've talked about so far, cables, breakers, earthing, it's all about managing power that's piped into our homes from the grid. But what about power you can carry around in your pocket? Let's take a quick look at the world of untethered power, batteries. So, batteries pretty much fall into two main camps. First, you have primary batteries. Think of the ones in your TV remote. They're single use. The chemical reaction that makes power only goes in one direction. Then you have secondary batteries, like the one in your phone. They are rechargeable because you can reverse that chemical reaction. Okay, I know this slide is packed with a ton of detail on all the different battery types. Don't worry about trying to memorize all of it. We're just going to pull out the 3 heavy hitters that you probably use every single day. And here are our champions. Lithium-ion is the rock star of the portable world. It's in your phone, your laptop. It packs a massive punch in a super light package. Then you've got lead acid. It's the big, heavy-duty workhorse, perfect for delivering that huge jolt of power your car needs to start. And finally, good old alkaline, the reliable marathon runner for things like flashlights and remotes. So think about it. Your house is filled with this incredible, complex system of cables, switches, breakers, and grounding, all of it designed to keep you safe from the power you're using. But after all of that amazing technology, what's the single most important safety feature in that entire system? It's you. It's your knowledge, your caution, and your respect for what electricity can do. All those components we talked about are your guardians, but you are the final line of defense. Understanding how it all works is the best tool you have to make sure that invisible power stays safe, useful, and right where it belongs. Thanks for tuning in.